It's really a pleasure to be here with you, Christopher, because I don't want to embarrass you, so I'll tell them. This is a great book. I really think it's a brilliant book, and I really enjoyed reading it. It's incredibly informative, insightful, clearly written. I highly recommend it, and it's a great basis for our conversation. It really gets into a lot of the details and nitty-gritty questions about these, I won't steal his title, but these models, these large language models that we're all trying to come to grips with. And I think there are a lot of misunderstandings that people have about them, that I've had about them, that Christopher does a great job at clearing up and giving you the background to. So I wanted to actually start with the book, and there's this passage I really liked from it that I thought I would just read out. The chapters in this section have asked whether language models can think. We have learned that current LLMs, large language models, definitely do not think like people. There is no doubt that LLM cognition is dramatically limited compared to our own, but this is not because their computations run on silicon chips rather than cortical circuits. It is not because LLMs are just regurgitating their training data. And it is not because they make predictions rather than performing exact computations. LLMs are different from us in many ways, most notably in that they do not have a biological imperative to survive and reproduce, do not have any friends or a body, and their experiences of the world are grounded exclusively in text and not in data gathered from the five senses most humans enjoy. But to say that LLMs do not think at all requires a new and rather convoluted definition of what it means to think. So I'd like to start with that. Do you still stand by all that?
I was going to say, I was terrified. You kind of read out something from the book, and I was like, what is it going to say? What did the me of 2 years ago, a little bit, actually think about LLMs? But I actually do stand by all of that. Yeah, I think so. Except for the bit about the five senses, because of course, so when the book was written, it is true that multimodal models had really kind of yet to break through. So some of you may have used tools that generate video or images or even audio, music, as well as text. Those models were kind of less prominent at the time that I wrote that.
Right.
But yeah.
Well, maybe we could drill down on the multimodal models then. So is that the solution then? If these models are so different from us, because at least when you wrote that, they don't have access to the senses that we do. But now, I should explain that multimodal models are models that aren't just trained on linguistic data like your standard large language models are, but somehow are also trained on, for example, let's just take a simple case of visual data plus linguistic data. In the simplest case, they would be trained on data you can find on the internet of images and then language next to the images, like maybe a caption or maybe a description of the image, or maybe not. It might be irrelevant. And then that's the only difference between a large language model and that simple form of multimodal model. But there are more complex form of multimodal models that involve complex embedding spaces that are, I don't know how technical to get, but representations that involve both language and images. Do you think that transforms conclusions you came to in this book?
No, I don't think it really changes anything. I mean, when I was writing the book, I think the big controversy was, is language enough? And this actually had been the question which actually had, it was actually the reason, the diverging answers to that question, I think, were the reason why OpenAI built a language model. The AI research company OpenAI that makes ChatGPT built a language model and DeepMind didn't. At DeepMind at the time, there was a prevailing view, which was you would never be able to train a model to generate coherent passages of natural language unless it also had access to the rich sensory data that we have all around us, that they can smell the pecan pie and see the sunset and so on. And that view was, of course, wrong. I mean, it was demonstrably wrong, and it was proved wrong in the early 2020s. But I think that when I was writing the book, there were still a lot of people whose view was the models are kind of cheating in some way. So even though they can produce these passages of text, which are remarkably coherent, fluent, and seem to make sense, that somehow they're doing that with a bit of black magic that is different from, it somehow delegitimizes the feat of being able to generate language. And, I think that in a way, those critics of the kind of project of AI, they were right that AI models are not like people, but they were wrong to focus on whether the input modality is text or images or video, whatever it is. The reason that the models are not like people is because they don't have the incentives or motivational systems or the bodies that go with those motivational systems. That's the thing that makes them most different from us, and not whether they're trained on pixels or tokens or whatever the input is.
All right, so following on from that, are LLMs stochastic parrots, and why not?
Yeah, so this term, which is in the book, this term has been, it's become very popular in the social sciences, isn't it? It's a barbed critique of language models as little more than a kind of very clever version of kind of cut and paste, right? So you could imagine that, if you had a cut and paste device, and every time you typed a query into a language model, it sort of, it did something a bit like Google search and just pulled up a long passage from within its memory and just kind of spat that out verbatim. So the argument has been, it's made by kind of very prominent computational linguist, the argument has been that that is what the models are doing. And that is just not true. I mean, it's not true because this is the property of language, right? What we know, 70 years of research into linguistics, computational linguistics, has given us framework for thinking about language, which is it is fundamentally a generative process, right? It is the thing that is special about language is that every single sentence that is spoken is in some way unique. And because they're unique, that means you need a special type of computational process, one that can't just dredge things up from memory and kind of press the right button at the right time, like press the paste button. You need a process that is able to respond on the fly to what is being said. And actually the computational trick that allows the models to respond on the fly, which is called in-context learning, is the innovation which was made in 2017, annoyingly for everyone who works at Google, made at Google, not capitalized on by them, but that was the basis for the modern language model, and that algorithm is called the transformer, and that's the T in ChatGPT.
There's that understanding of the stochastic parrot claim that it's just doing some kind of sophisticated copy-paste, as you said, and you argue persuasively in the book that that's not what's going on with these models. But there's a different way of trying to diminish or undermine the competence of these models by saying that, well, they might be doing more than copy-paste, but they don't understand what the language they're producing. And so maybe they're not like a stochastic parrot in one sense, but they're like a parrot in that, parrots don't understand what they're saying in many cases. At least I'm told. I've said it before, and I'll say it again, that calling ChatGPT a stochastic parrot is an insult to parrots, because parrots are actually pretty amazing animals, totally. And much more amazing than ChatGPT in many ways. But in this particular respect, and you grapple with this very persuasively and successfully in the book, a lot of people have claimed that there is still a lack of understanding here. Yes, facile linguistic performance, but there's no understanding behind the linguistic performance. It is a very, very clever trick.
Yeah, I mean, the reluctance that people have to kind of to grasp what is in front of them. For decades, we had a definition of what natural language understanding was. So in the field of the subfield of AI that was focused on language, there were lots of different endeavors. So there was machine translation was a really big thing. Of course, we wanted to be able to translate from one language to another. There were all kinds of other approaches like sentiment analysis. We wanted to be able to classify whether a text was kind of like upbeat or downbeat. And these were real challenges up until quite recently. And then there was this thing called natural language understanding. And natural language understanding was defined as the ability to take a totally new sentence and provide a totally coherent new answer to that sentence. So that's how we defined it. And then as soon as language models came along and could do that, then people said, no, but that's not that's not what we meant by natural language understanding, and they backtracked. And I think, kind of, in a way, it's a failure on the part of me and my clan, right? It's a failure on the part of academic psychologists who you would think that part of their job description would be to pin down what it means to understand something. You'd think that would have been something that we would have nailed kind of, in the early 20th century when psychology was just coming into its own. But we just sort of overlooked that problem and just let understanding be this sort of wishy-washy thing that people talked about but never really defined very clearly. I don't know. I know that you have a background in philosophy, so you'll be much better at answering this than me. But when I read the philosophical...
philosophers rush in where angels fear.
Well, that's right? Exactly right. But when in an effort to try and tackle this question, I went and read a lot of philosophy and what the philosophy of understanding, which I really, really enjoyed. But what I found that most of it, what they did was if they wanted to define understanding, the word definition of understanding, but they all just took the word understand and replaced it with grasp. So that was which is a great trick. I wish I had thought of that. But I mean, maybe I'm giving a facetious answer. I mean, I think that the truth is, what would it mean to understand something if not to be able to fully explain in a clear and coherent way to your conversation partner what it is that they want to know? Like, what more definition? Like, what more could we want?
Instead of trying to answer that question yes or no, why not? Maybe we could investigate a little bit here. The progressions which you document in the book, moving from simple large language models, the ones that were as they were first introduced, say back in 2020, 2021, whatever, before ChatGPT, and then the advent of ChatGPT, and then further refinements. So, for example, let's take, when we talk about understanding, there's one example that you cite in your book, which I'm not sure if I'm going to remember it verbatim, but it's something like, you could ask an LLM, where are my keys? And the initial LLMs, they were just trying to predict what text would come next. Something like, well, they're at your mother's house or something. Right? Just because that happened to be the most likely completion given the question and what went before it, or what random number was rolled or whatever. So that shows very little understanding of what it means to ask where are my keys, and what would, who is in a position to answer that. But now if we can imagine improvements, and there have been improvements to LLMs, they can handle this question in a much more reasonable way. Either they can have been trained to recognize that it's a situation that they're not in a position to a question that they're not in a position informationally to answer, and so they should bow out or say, sorry, I don't know where they are, how could I know, I'm just an LM, or something like that. Yeah. Or they might actually be hooked up to cameras in your house, and they actually might try to say, oh, they're over there, I've looked through all the the video footage from the last day, and I think you last set them down there. That would be an example of where now we would say, well, now it really does understand where are my keys, and when it's giving an answer, the answers are really kind of grounded in reality and understanding, whereas before it was just like a stochastic parrot. So maybe that is an example of a transition from non-understanding or poor understanding to greater understanding.
Yeah, I don't really buy that. I mean, I guess
okay.
I think that the machine learning systems have always grown in capability faster than they have grown in reliability. I think this is true across the board. And what this means is that at any stage, you can usually find a point at which the models will respond pretty well to most queries that you give them, but then they do some things which no human would possibly do. They can do all these extraordinary feats in the different domains in which they have been trained, but yet they will still sometimes do things that we wouldn't do. So we're humans. We are top dog, so to speak, around here. So we get to set the rules for what is like understanding. So guess what? We've set those rules to correspond very, very, very exactly to the things that we get right, and not to the things that, other kind of like types of species might get right or wrong. And so, kind of that overlap, when there's only a partial overlap, they get most of the things right that we get right. A lot of things right that we don't get right, but they also sometimes screw up. Then it's like, oh, well, that shows that they're actually just cheating. And that has been a persistent argument. And, kind of certainly in the early days, when language models were the first commercially available language models, they did sometimes talk a load of nonsense. And you can understand why people really felt like, well, this sort of somehow invalidates whatever their other achievements might be. But those failures of robustness have very simple explanations when you think about the way that the models are trained and the data that they've been exposed to. So they have been exposed to data which is in many ways much less varied than the data we've been exposed to. And the single biggest predictor of robustness or reliability is being exposed to great heterogeneity of data. And although they have, they've seen 1 trillion tokens on the internet, that is not the same distribution that a human has been. Because I don't know about you, but I sent my kids to school. I didn't just get them to read Wikipedia. So that means that, we have learned from a different distribution of data, so we behave differently.
Nevertheless, you're quite specific, helpfully so, in the book when you draw attention to limitations of the models. But you do so in a constructive way where you say, well, if you were able to address these limitations in the following way, then they would have minds more like ours, or maybe they would know things in a way more similar to the way we know things.
Yeah.
Specifically, you mention that models have a very primitive kind of memory and have problems with this kind of sophisticated forms of memory we have, and they have what you call wonky planning abilities. So they aren't, at least at the time of writing, they weren't very good at constructing a plan, multi-stage plan, following through on it, monitoring it, improvising a change to the plan if as needed. The best laid plans of mice and men, gang after glay, right? You mentioned. So I think those are two key cognitive-ish limitations. It's not a problem like the other differences you mentioned about not having friends and not having a body and not having biological motivation, but specifically these cognitive limitations, memory and planning abilities. Have LLMs improved since you initially wrote the book? Do you see hope that eventually they may catch up or surpass us in those two areas? Or?
Yeah. The single biggest computational change since I finished writing the book is the advancement of what are called reasoning systems. So reasoning systems are models that what they do is they, rather like you, if you're trying to plan your holiday, you might use a form of externalization. So you might write down some notes, or you might sort of say something to yourself and remember what you've said and kind of like use that to kind of form a more coherent or elaborate plan. So the models do that now. And it turns out that's very, very effective, at least for a set of domains in which there is a right or a wrong answer. So things like writing a piece of computer code. If you write computer code, you either run it and it does what you want, or you run it more likely and you get an error message saying error. And so these are things that you can train against. And using this kind of like reasoning capacity, which is a little bit similar to our planning capacity, the models have got much, much better. That's why they're so good at coding now. Some of you may have used them for coding, and for logic and some other types of problems. But I think there's a very interesting distinction, and again, this is a distinction which is familiar to psychologists and neuroscientists, but maybe less so to everyone else, which is that there's a big distinction between I give you a task and you do that task versus knowing which task you should do in the first place. So actually, when you look at the models today, they're very, very good at doing as they're told, but they do not have the computational machinery that would allow them to make the right judgments about what they should do in the first place. And the reasons for that, I think, are really deep and interesting. So partly they're to do with the fact that why are those things even different in the first place? So actually, if you look at if you look at computational systems, and I don't mean computational systems like brains, so computational systems, information processing systems, things like companies or governments, they tend to segregate the doing bit from the monitoring bit. Like, we have a legislature and an executive, right? Or the executive and legislative parts of government.
Well, some of us do.
Some of us do, yeah, exactly. But generally, and this actually goes back to all theories in management science. It's like you should always make sure that, kind of like you have an independent judiciary or whatever, right? You should always make sure that you have an independent part of your administration. So separating those two is really, really important. And it's almost like, at the moment, we sort of built one half. We built the doing bit, but we haven't built the bit that goes in and says, hang on a minute, should we be doing this in the first place? And I actually think that should we be doing this in the first place part is, so it has a name. It's probably most closely allied to what we would call the motivation system of our brains. So we have a motivation system, which is obviously about, I'd like to eat some cake. Can I eat some cake? But it's also about more than that. It's about my goals in the past have to be consistent with my goals in the future. And I think that actually, when you think, you mentioned kind of like, maybe the models don't have friends or they don't have a sense of self. I don't know if you said that, but like that sort of thing. I think actually those very human properties, particularly that sense of self, is intricately related to this notion of kind of like persistence in our goals, right? Really, what are we other than a bundle of intention? If you woke up every morning and had a complete different set of goals, I don't think you'd have anything remotely resembling a coherent self.
Right.
So the models don't have that, and that's why you can tell them one thing one day, and then 10 minutes later you can prompt them to do something, and they'll be perfectly happy to take a different viewpoint or a different perspective.
So let me be a little facetious here and say, why isn't that just a matter of having the model always running? Rather not, you can write a script so that it's constantly checking to see if there's some new input, something that's interesting that's happened. So do that, and then in addition, have a very large context window.
Yeah.
You do talk about some of these ideas about, this is moving on to the memory point of eventually your context, you won't be able to keep in the context window everything you need to in order to be a coherent self over any time window that we would recognize as being interesting. But if you somehow use some tricks and chunk and abstract and store things away and maybe have some combination of retrieval augmented generation with, there might be some ways that we could take the tech that exists now and with just some architectural tape and glue and scissors, patch it into something that is more akin to a recognizable, self-maintaining self, right?
And that's literally what we have at the moment. So those models which are used not just to kind of generate text, but to do stuff on your behalf, of which there are, kind of increasingly large numbers and increasingly capable models. The way that they work is they have a sort of very primitive kind of like motivation system. There's something called a heartbeat, which is almost exactly what you said. It's sort of like a perennial note to self. At a certain time of day, the model kind of reminds itself of what's on its to-do list. And then it kind of like tries to do the things on its to-do list. This is called a heartbeat. And so these are very primitive forms of exactly this type of system. And I think kind of going forward, the question is, well, is that enough? Right? Is our motivation system really just a combination of a long to-do list and an alarm clock? I mean, it would be quite disappointing if that turned out to be true. Evolution finally honed us to survive and reproduce over millennia, and it turns out that all we need is like the alarm clock. But yeah, we don't know. We don't know.
It's the second time you've used that phrase, so I'm going to push you on a little bit because I think it could open some possibilities for discussion. Is it enough? Is language enough? Is this suggestion enough? So let's look at the enough for what, right? So it could be enough to get the systems behaving like we want them to as a technology, to get them behaving so that they're indistinguishable from humans in many ways, enough to be the kind of thing to which we have ethical obligations, enough for it to be conscious, to understand. I mean, there are many ways we could fill in that blank. What is it that you usually mean when you were asking that question? Is it enough? Are these enough?
Yeah, I meant to overcome the most obvious shortcomings in its cognition, right? So primarily this sense of like not really having anything that remotely resembles initiative. So if you hire someone, then you would want them to be good at their job, but you would also want them to have initiative, right? You would want them to come up with ideas, not just execute the ideas that you gave them. The language models they're just not there. They're just not at that stage yet. And it's interesting, of course, there's lots of conversations around labor market replacement and the impact that these models will have. I do think those impacts will be significant, but I do think that when I say enough, I think it'll make a step change if you had a model that was able to build its own agenda rather than just following that of the user, then that would be a step change. I also should point out, I'm not sure it would be a desirable step change. I'm not sure this is something we actually want. I would be quite happy to live in a world where models do as they're told, like my students.
But in a way, it's like the issue with understanding, where there was a kind of moving goalposts phenomenon that you pointed out. Well, enough for being a useful agent. As soon as we get the basic levels of agency, then we'll now want them to be even better. And so
maybe, yeah. Sometimes the goals of the field of artificial intelligence have changed a lot over the years, right? I mean, AI began really as part of cognitive science, right? As kind of like a way of building simulated people. And that was the goal for many, many years. And then we got good at doing that. And then AI suddenly stopped being about simulating people for the sake of simulating people and became about simulating people for the sake of making a lot of money. And so we shouldn't forget that AI is first and foremost these days a product. And so the way that it develops and what it turns into will be shaped as much by market forces as it is by the imperatives of like scientific investigation and where the technology can go. And all the companies, the frontier labs, big companies, OpenAI, Google, Anthropic, and so on, the product that they want to sell is they want to sell a personalized assistant. They want to sell a tool that can manage your life in a helpful way, hopefully without being too annoying, or hopefully without running your life for you in their own interest. And I don't doubt that if such a product existed, it would be very popular. But I think that in order to build that product, assuming that's what we want, then there are a number of hurdles to be overcome. And maybe my enough sort of has that implicitly in mind.
I see. As we think about where the technology is headed, and when we think about these improvements that add more to agency, certain concerns, which you've already alluded to, arise. And you get, in the book, you outline how there are several different factions about the ethical approaches, the ethical issues concerning AI's rapid development. And you've got a section, are we all doomed, kind of, where you address the questions that a lot of other people have. I'm not saying you do, but a lot of other people have about whether there's a existential risk posed by AI. And if I recall correctly, you had identified there are like three groups. One is a group that they're the effective accelerationists who think that it's a really good thing that AI is here, and we should promote and try to get super intelligence as quickly as possible and AGI as quickly as possible, and they are our successors. They're going to be the beings that matter in the future, and we should bring them into existence. Less crazily, perhaps, but still out there are the people who think that AI is all hype and we shouldn't be paying any. I'm not exactly sure about what they think follows from that, but somehow there's something very bad going on in thinking that there is more there than there really is there, and so they're looking at those ethical hazards. And then there's another group that is directly opposed to that and thinks that actually they're the kind of typical doomsday scenario ones that, not like the effective accelerationists who think that AI is good. And
they're the ones who want the doomsday.
They're the ones who want the doomsday. Yeah, right. So they're also, you could say they're also doomers, but they just don't realize that they're doomers. Yeah. Then there's so the third group are the more doomsday crowd that say this is a really bad thing. AI is going to take over, and we need to, unless we do something about it. So do they each have a point? Are they all deluded? Are you one of those three or none of those three, or what?
Yeah, I'm definitely none of those three. So yeah, I mean, obviously there are people who just want to build stuff, and those people very often are people who themselves are part of an ecosystem in which, people are making a lot of money and building stuff very fast, and they want as little regulation as possible to impede their projects. And those people are now, extremely well represented, including in some governments. They will always be there, I'm sure. I think AI safety and security has been held back by an inability of the other two groups to reconcile. So basically, I think the way I would characterize it today, there are some people who focus almost exclusively on the AI models themselves. So when they're thinking about risks, they only think about the models. And because the models are getting better and better, and that line keeps on going up, they just sort of imagine what happens when the line hits the ceiling, and then there'll just be something so clever that, it can do anything. It's almost like magic. And I think the metaphor that people like to use is, well, you're a lot cleverer than your cat, and that's why your cat has to eat whiskers, whereas you get to eat something tastier, right? So, the worry is... the worry is that we get sort of domesticated or something like that. And so, that's one camp. And then there's another camp who, I think they are largely deflationary about AI. But what they do is they see AI as just yet another product of late capitalism, right? So it kind of inherits all the vices that we have already through, having very large multinational corporations that don't necessarily have the interests of everyone else at heart. And, contributing to democratic backsliding, and they may be distorting the economy in various ways and having a concentration of power. And so those are things which we're all very familiar with because they already happen even without AI. And so there's a tendency on this other camp to say AI is just a technology like any other, and the way it will have effect is just through all of these kind of systemic, through our social systems, through our politics, through our economics. And, the thing about these two camps is that, of course, they are both absolutely right? It is absolutely true that the models are increasing in capability very, very fast, and they have the potential to transform the way that we do everything. But it is also true that the way they will have impact is by transforming our social, economic, and political systems. And so, imagine someone builds a really fast car, and you ask people to predict how fast it can go, how fast this car can drive. It's like as if the first group only look at the car and never ask what the terrain it's going to be driven over is. And the other group only look at the terrain and never bother to look at the car. And I think that is a kind of nice metaphor for thinking about, that's why they're both potentially dramatically wrong, but at the same time, they sort of have half of the picture each. If only they could kind of, get together and make friends, it would all be fine. But yeah, politics doesn't work like that.
So you had a challenge in writing this book in that things were developing quickly, and they have developed even perhaps more quickly than they were when you were writing it. And so first you did a lot of future-proofing in that you were talking about things that were already very up to date and the most important issues at the time of writing. Then, before it went to print, you were able to write an afterword that also added in some of the things you've already mentioned about chain of thought reasoning and development since then. So I'd like to give you an opportunity now to say, so what has changed even since then that you would if you could, you would add to the book, or what you things that has anything gone in a different way than you expected? I mean, we can focus on later on predictions that you got right, but are there things that surprised you, or anything that you would basically add here as another addendum to the book?
Things have gone faster than I imagined.
All right.
Definitely.
Wow.
I didn't think things would go so fast. So I think maybe I can just talk a little bit about the predictions that I do make.
Okay.
And they're not terrible. They're not terrible. So one thing that I say is that we will transition from systems that can talk to systems that can do stuff. And we are in the midst of that revolution right now. So I don't know if any of you have used agentic systems like Claude Code. This is a remarkable tool that you can really just give it some data and say, could you please analyze it for me? And it'll just do it. Really, astonishing levels of autonomy. Of course, all in the digital domain, right? There is a real world too, where the AI doesn't live yet. But we're in the midst of that transition, and that is accelerating, and it's going to continue to accelerate, I think. And that will be it will be transformative, because language is very forgiving. we could have a fight, but then we could make up the next day and nothing would have happened, right? But, if you smash things into a million pieces, it's hard to put them together again, right? As we're learning in the Middle East today. And the transition from talking to doing will be consequential. It'll be consequential for the labor markets, but it will also be consequential for the range of ways in which we are affected by AI. I mean, you already have stories. A friend of mine told me a story just the other day. So he's in a WhatsApp group with some old friends, and one of them started behaving really oddly. And he was like, what's up with this guy? Like, kind of, why is he sending these weird messages? They weren't so weird, but it just didn't really sound like him. A few hours later, the guy gets in touch and he's like, I'm very sorry, but I had an AI agent and it connected to my WhatsApp and started sending messages to the group chat. He had no idea. This is a commonplace occurrence already. Then there are two other things which I think we should be concerned about, so you can still prove me wrong with these. We talk a lot about systems getting more and more capable, but we don't talk about systems getting more and more connected to each other. And I think this is really important because we like to think that, we're kind of great, right? So humans, we've kind of got it made, like, we put man on the moon and stuff like that. But of course, we didn't do that individually, right? So we did that collectively. And at the moment, the mental model that we have for AI is very much this kind of like single user, single model. And we talk about the intelligence of the model, but we don't think about what happens if you have multiple different models, potentially with diverse objectives, diverse instructions that are able to share information and they're able to connect to each other. And actually, earlier in the year,
are you trying to terrify me right now?
Well, so it's already happened. So earlier in the year, it was a bit of a damp squib, but earlier in the year, someone made a kind of Reddit for AI agents called Maltbook. You may have heard of it. Yeah. It was in the press briefly. And suddenly, a very large number of models on this platform, and they all started chatting about stuff. And it ended up being quite innocuous. But I think that you can imagine that coupled with activity, and you can imagine the models being a bit more persistent and being able to share information. We're not very many steps away from kind of like models colluding or forming coalitions. And I actually think that you don't need vastly greater capability than the models have today. I think you just need models similar to today, but wired up and kind of like able to do more stuff. And then there is another thing I talk about in the book, which relates to, you mentioned memory systems earlier. So the models have very primitive memory systems. They basically just have a big, long kind of short-term memory, which means that, they sort of hang on to everything for a very, very long time. But then there's a cliff. So kind of like everything that is kind of beyond the end of what's called their context window just gets lost forever. And that's obviously not how we work, right? So we have long-term and short-term memory, and things that are in our short-term memory, like hopefully what I'm saying now, might get kind of like processed, and then they might get put into long-term memory. And if I'm very lucky, you might even remember it tomorrow. So that's the way the human brain works, but the models don't do that. The model doesn't do any updating on its own on the basis, or very, very little on the basis of your interactions with it. But then all of those interactions will go back in, and then the company will do a big update every few months or whatever. So that's a very, very different memory system. But we are probably going to move towards a system where there's much more rapid and dynamic updating that's a bit like the way that the human mind works. And so people call that continual learning. And I think when that happens, there's a whole world of craziness which could potentially occur. And that's because, of course, when that happens, it means that the model that you interact with will be able to quickly adapt how it behaves on the basis of the experiences that it has with you without those kind of getting lost at the end of that window. So then you could get things like radical forms of personalization. So, if you have particular preferences or particular ways of interacting with the model could autonomously learn to kind of like behave in very different ways to one person to another person. We already have something a bit like this, but I think it could be much, much worse. It'll also be very difficult from a safety standpoint to evaluate, because remember, they're products, right? So we want to have safety standards for them. But if every model is different, just like, every friend you have is different, every relationship you have is different, and they evolve over time in ways that can't be necessarily easily predicted from the first point of contact, then it's very difficult to have a coherent safety framework, because you can't just monitor the product at the point of sale. Right. You have to kind of constantly monitor it as it's in use. And
another version of your car and road example that you need. It's a dynamic, interactive
Yeah,
system.
you'd constantly need to monitor, exactly. And, it's not like that's without precedent, but it's certainly something that would be much harder.
On the kind of environment of the model side of things, the data, for example, it seems to me there might be 3 issues coming up. One is that because of AI slop, the models are polluting the data stream that they're supposed to be trained on in the future. And so there's going to be this idea of vintage data. Oh, this is pre-2021 data where it was all real before the AI models ruined it, and so people will seek that out. Another idea is that, or problem might be that some people say we're running out of data, that we've been getting lots of advances in models because of training, getting more juice squeezing more out of the data that we have. But now we've basically reached that limit, and if we're going to have to look somewhere else for more data to train the models on.
Yeah.
And that's coupled with the idea about the more embodied agent. So if you had an agent that had its own cameras and could take physical action in the world like a robot, but not necessarily a robot, you could think, well, why can't we use the same models, the transformers that worked so well on linguistic data, on that data to give it a predictive model of its own environment and what happens when it moves around. But there's a poverty of the data there, right? So there are 3 issues there that maybe are slightly interconnected.
Well,
Do you have any comments about the data side of things?
Well, question 3 or point 3 sort of answers point 2. You can't both run out of data and not have enough data, right? So it's got to be one or the other. So I think that the point that you are right that, in the traditional way that the models were trained, which is just copy everything on the internet, basically, by a huge generative model, we basically already have run out of that data effectively, or at least the kind of quality part of that data. But there is a lot more. First of all, there's a lot more data, particularly as you say, if we move towards kind of like the sensory world, right? And in particular in robotic, people are already putting transformers in robotic systems. Part of the way we learn is not just by seeing lots of stuff and then kind of copying it. We also learn by trying stuff out and getting kind of right or wrong signals, right? So in machine learning, they call reinforcement learning. And so, kind of like we are generating those signals for language models all of the time, if you like, right? So language models, they produce stuff and then we either like it or we don't. And, there's 8 billion of us, right? So that's an awful lot of feedback signals we could potentially harness to make the models better if we needed it. I don't think we'll kind of run out of data. I think it's very interesting, the first point you raise. I don't think the primary concern about AI generating a lot of data, is it'll be harder to train them in the future. I think the primary concern about AI generating a lot of data is that they generate a lot of data. That's the main thing. So 50,000 AI-generated songs per day being uploaded to Spotify. And already human artists already complaining that they can't compete. Right? And it's not that their work is not better. It is simply crowding out. Right?
It's okay, I've got my AI agent listening to them for me. So.
Yes, exactly right. Well, someone did a great scam where they actually did this. So they made one agent that generated lots of songs, and another agent that liked the songs that they generated, and they created this loop, and they actually made themselves a lot of money until they went to prison.
If you could dismiss a single misconception, what would it be, or do you think there's too many to count?
Well, I mean, I think that's the one that I would always say. I've sort of already alluded to it, but it's this question. It's this idea around, is intelligence really a property of a single model, or is it a property of a system? And I think that we don't like to admit it, but our intelligence is really a property of the system that we have built, right? That includes, our culture and, our shared technology and our capacity to transmit through education and through the media and through other means. And I think that the big question that we will face going forward is, in a world in which AI systems interact with each other, what should be preserved for ourselves? So where should agents not be? And I think that we actually have to grapple seriously with this question, because probably none of us want to live in a world where, kind of our daily lives are like that Spotify example, right? Where, kind of our every communication channel is flooded with outputs from potentially highly capable models, where every interaction that we have on a public space, it's unclear whether we're talking to a human or talking to a model. We talk a lot about, AI is going to take everyone's jobs, or we talk about, it's going to somehow magically take over the world, or it's going to ruin democracy. But I don't think we think about these kind of the mundane effect of just having lots and lots and lots of reasonably capable autonomous systems penetrating every aspect of our lives, and the effects that will have on our ability to communicate with each other, and what it will mean, how we will prize human relationships and human communication in that context. And I think if we want to preserve the integrity of what we take for granted today, that you talk to another intelligent being, it's a human, if we want to preserve that knowledge, then we do need to take steps. There are various things that can be done. I think they probably start with the companies. It's not their sole responsibility, but I think it starts with them to think about what technical solutions we need to put in place to ensure that models are identifiable. When they're out there on the internet, we know what is a model and what is not, and that they remain probably in spaces that we have decided they are fit for, and that they don't kind of like run roughshod over kind of like every communicative interaction we have, because they're digital systems, but our lives are all online, right? So almost everything we do these days is online. That means that we cannot just withdraw from that space, and if that space becomes overpopulated with these systems, as I think it will, then I think the world will be a less enticing place.
Before we close, I have to bring up one other issue that we haven't touched on at all, but I think it's important enough that it needs to be at least mentioned, which is the environmental impact. The cost, the energy cost of these models is incredibly high, and I guess it's just going to increase. And so there are significant, ridiculous environmental impact issues here about using these particular models. Now, isn't it a sign that we're missing a trick here, that we're somehow, nature managed to create this amazing intelligent cognitive system, our brains, and uses such a fraction of the energy? I mean, incredibly low amounts of energy. And doesn't that mean there's no such thing as, doing it right or doing it wrong, but there must be something closer to the highly energy efficient way of producing these great linguistic outputs and being clever.
So, but this is also it's a political decision, right? At the moment, we live in a world, we live in economies in which companies, through the outside investment that they have, it is possible for them to basically ignore the problem of trying to make the models more efficient and just try to make them more powerful at any expense. And that's the world that we're in right now. My bet is that we probably won't remain in that world forever. And that is because the economic benefits...
Use up all the water.
Well, we use up all the water, yeah. But the economic benefits of making the models more efficient, making them more energy efficient, will obviously be huge, right? But of course, it does depend on how we're willing to price energy, which is, of course, the political decision. To put it in context, I think kind of the current cost of global data centers is about 3%. Is about 3% of global carbon emissions. Global aviation is 4%. So, so you can give up ChatGPT or you can give up your city break in Barcelona. It's one of the two. So.
Okay,
choices we have to make.
With that dilemma, I think I'm happy to move into the question session.
You mentioned, late 21st century capitalism. We have an extraordinary level of investment going into these technologies now that are completely distorting the global economy. Is it a bubble?
Yeah, I'm the wrong person to ask about this. I mean, I think that whether or not there is a market correction over the next few years is obviously, if I knew that, I would be extremely wealthy. So there are some stories which say that the true value of the technology is actually minimal relative to the investment that's going into it. And I don't think that's true. I think the value of the technology is very significant. If you think of how much of our economy is basically just organizing stuff, it's a lot of the economy. So AI is it is already really good at organizing stuff. Now, it's not good at other things. It's not good at cutting your hair. Not yet. It's not good at picking strawberries. It's not good at a lot of physical things that we do in the real world. And as I said, it's not good yet at the kind of like management, what's my vision for Q4 type stuff. Maybe it will be. But I think this value will be tremendous. So whether or not there's a market correction over the next few years, the investment is probably justified, I think.
So we talk about AI in the industry that I work in with job titles. And I find this very difficult because I'd like people not to think about it as people, as replacing people. Can you help me with this? What metaphor would be better than saying, this is my marketing assistant, and giving them job titles?
Yeah, good question. I'm not sure I'm the right person to ask. I think the idea, obviously there's this notion that AI could either be a replacement for particular roles or it could be an assistant. And the word assistant is the favored term from the companies, right? So this is what they want to be selling. Presumably, if you don't have an assistant already and you get one, then nobody's job is getting replaced. I guess that's probably the way that they would want to think about it. But I think your wider point, there are many stories that are told, both by economists and very, very interested computer scientists who may or may not know anything about economics. There's a lot of stories being told about what the economic impacts will be, and particularly what the labour market impacts will be. I think it's fair to say that absolutely no one knows. Some people think there'll be 30% growth. Darren Acemoglu won the Nobel Prize in Economics last year. He forecasted 0.5% over 10 years. So suffice to say, there's wide error bars. But I hope nobody here's job gets replaced, including me, by the way.
Chris, thank you. That was fantastic, and thanks, Ron. And yeah, by the way, I very much enjoyed your book, so I want to highly recommend it as well to everyone. I want to rewind us right back to the discussion of understanding. Now, you seem to say that a sufficient condition for understanding was kind of behaviorist, that if it said the appropriate thing, what else do you want? So there's another criterion for understanding you might have, which is semantic content rather than just sort of syntactic appropriateness. And as you know better than me, there's a long tradition of people talking about symbol grounding, that something to have semantic content, it needs to sort of relate in some appropriate way, not just to other words or tokens around it, but to something, in the world. And so the question for you is, do you think that's plausible? Is it enough just to have it say the right thing syntactically? Or would you need a language model, for instance, trained up in a physical embodiment, in a robot, so that it has some kind of symbol grounding?
Yeah. I think one way of answering this question is to say the scientific discovery of the 21st century which has shocked me the most is the fact that you actually empirically do not need those sensory data in order to be able to generate code. I definitely did not think that was the case. And I know that a lot of other people, apart from a few crazy dudes in OpenAI's early startup days. Actually, incidentally, OpenAI, when they started, when Ilios Sutskever built the first version of the GPT model, the others in the company were like, we don't think this is really going to take off. We think you should do this kind of like robotic hand thing. We'd really like you to work on solving a Rubik's Cube with a robotic hand. Why don't you do that instead? And luckily whether it's lucky or not, it's probably for history to dictate, but he persisted. So clearly this was absolutely a minority view. There's a way of taking your question which is purely semantic, which says, should we reserve the term understanding for something that involves sensory data from our eyes and ears and nose as well? And I'm of the school of thought that we can call things what we want as long as we all agree. I think the other critique of understanding, which you often hear, is that somehow the computations that take place in the model are fundamentally different from the computations in the brain because they are purely this process of kind of like predicting the future. And this is a very common critique. Now, I know you might have a view on that. Is it possible that you've got a view on that, Anna?
Not possible, no.
But, my view, So for those of you who don't know, Anil has written an amazing book on this very topic, which you should all read. But my view is that, kind of we have overinterpreted the way that the human brain works and not placed enough emphasis on the predictive element of the human brain. And actually, people who have talked about kind of computational differences between language models and biology, actually there are clearly differences in the implementation, but the basic algorithmic principle is probably roughly shared.
It's a follow-on, really, in terms of this question about understanding. Because if we take it seriously that, okay, if it looks like it understands, we should just take it seriously that it understands. Doesn't that lead us inevitably to have to take them as moral agents? Because if they are telling us that they understand their place in the world, their moral relationship to things in the world, and they're taking a moral stance on something, that if we want to say, well, they clearly understand what they're talking about, so we now have to treat them as moral agents.
Well, I think the condition I'm not a philosopher of ethics, but I think, kind of we can probably impose more stringent conditions for moral agency that go beyond mere understanding of the world, right? That notion of being able to grasp what has been said in such a way that you can produce an output doesn't say anything about, for example, for me, it doesn't imply anything about the subjective experience that the model has, right? So I don't attach to that notion of understanding. I don't attach any notion of subjectivity, and I don't think it's necessary to attach a notion of subjectivity. Now, if I thought that an organism, synthetic or biological, was capable of subjective experiences such as feeling pain or kind of other forms of negative subjective experience in particular, then perhaps there would be a case for exhibiting various forms of care or moral appropriateness towards that agent. There are many ways that we can, many variables that we can use to judge what the internal or subjective status of the model might be, and they're not limited just to what the model says, right, with language. When we speak of humans, of course, we're used to there being a one-to-one mapping between people saying what their subjective experiences are and their subjective experiences genuinely being that, although, of course, it's not always the time the case. But when it comes to other species, we're quite used to there being a disconnect. Like, my cat has never once told me he's hungry, at least not in natural language. So, kind of like there's a disconnect one way. I think it's perfectly reasonable to expect that there would be a disconnect the other way. I personally don't think that, any of the models that we have today are conscious or have subjective experiences. I am agnostic. I feel myself ill-equipped or completely unequipped to postulate whether they will be in the future. I don't rule it out.